Hey, good morning, guys. This is Bharath. Today we are going to look about bubble sort, which is one of the simplest and most intuitive sorting algorithm that's known to mankind, I would say. So, uh, this is very intuitive in the process. It's just as how you would arrange stuff around it at home. That's how simple this sorting algorithm is. So, just remember the way that you sort things in your house. That's the same way that you're going to do it. And the reason bubble sort is very interesting. It just means that you're bubbling up your answers through the list of elements that's given to you. That's why it's called as bubble sort. You would understand what bubbling up means once I explain the algorithm. Let's look at the algo now. So the algo is just basically very simple. It's just three steps. It's purely intuitive. So let's say you want to arrange three sticks that's given to you, or let's say the three fingers of your hand that you want to arrange. So usually pretty much your middle finger will be the tallest, your index finger or the pointing finger will be the uh, next next biggest, next then your ring finger will be the third biggest. That's how it's in my hand. So what I would just do is, if I need to sort my fingers around, all that I will do is I'll just compare one next to the other. So first I take my index finger, compare it to my middle finger. I see my index finger is lesser than my middle finger, so I need not move this around. So that's a given. So now then I take my middle finger and I compare it with my ring finger. Okay, yeah, makes sense. It should move to the right because my ring finger is smaller than my middle finger. So I just swap my fingers. So that's a similar kind of logic that gets applied here. So let's say you need to traverse your set of elements from the left to the right, based on what type of sorting that you want to do. The comparison operation might change. Let's say we are doing ascending order. What would happen is, as listed in the example on the right, so you move from left to right. So your initial starting is 50, 25, 5, 20 and 10. So you take you for 50 and your 25, compare it. Yeah, 50 is greater than 25. Yeah, makes sense. Swap it around. Just move 25 to the left, move 50 to the right. Now then take 50, compare 50 and 5. Then that means what's happening? 50 and 5, swap it again. Then 50 and 20, swap it again. 50 and 10, swap it again. And at the end of the first iteration, you will see that your 50 has moved all the way to the right. This is what bubbling up means. So bubbling up means moving your element, or bubbling up your element, or the bubbling up the largest element towards the right of your array. That's what it means. That's what bubbling up means. That's why it's called bubble sort. Repeat the same operation in for the again from left to right. So you start from 25, compare 25 and 5, 25 and 20, 25 and 10, and yep, you need to swap in all cases. Just swap it around and move it, and you can see. And but you don't compare 25 and 50. That's the reason for it, because 50 is the largest, and you always, once you start doing bubble sort, for every iteration you fix the position of one of the element in your array. So in the first iteration, or the first pass, that's what we call each time you go through the array, it's called a pass. In the first pass, you just find your largest element, move it all the way to the right. That's what's happening. That's why 50 moved all the way right. So in the second pass, you can see you took another element. You don't know which is your largest, but at the end of the second pass, for sure your second largest element will be moved towards the right, all the way to the right. The same thing happens in the third pass, where you start with 5 and 20. No need to change because 5 is less than 20. Then you come at 20 and 10. You need to swap it around. Now you can see that 20 has moved all the way to the right. 10 then do a next then you do another pass. You compare 5 and 10. There's no reason for swapping. Just keep it as it is. Yeah, well and done. Yeah, you're done. Now you say 5, 10, 20, 25 and 50. There is a reason why you don't go to the next pass, because you take 5. What are you going to compare it with? There's literally nothing you can compare it with in order to put its place there. So it's basically like you put all the other piece of puzzle together, and the last piece that you saw somewhere lying on the floor will automatically come and slot it. That's how 5 gets slotted in the left place. So that's this explanation is what is represented in the left. So you traverse from left to right. That's what we're doing at every pass, and compare adjacent elements and keep the right higher one is placed on the right side. So 50 and 25 got compared, which is on the right side. So 25 and 50 is swapped, then 5 and 50 gets swapped, for 20 and 50 gets swapped, and it goes on. So it's the same thing, and do again and again and again. How many times do you do it? You do it one time lesser than the number of elements that you have, because once you arrange 4 things, the 5th thing will automatically slot in to its proper place. Let's take a look at the code. I prefer I prefer to write code than show a typed up version over here. So let's move out, go to my code editor. Yeah, this is my code editor. I am using collab for mine. If you want, you can use collab. That's up to you. So basically, first you need to move from left to right. So write a for loop for let's declare a list of variables. A equals 1 comma 3 1 comma 5 comma 6 comma 0. So let's have an array like this and have one more element for just for the heck of it. So yeah, for I in range, so to move from left to right you need an iterating variable. So let's say for I in range 0 comma n, then only you will move all the way from the left to the right. Then you get for j in range 0 comma n minus I minus 1. The reason for this is, as we saw in our algorithm, as you do 1 passes, the rightmost variable gets set. So that's this concept of not having to compare the 50th or the last element in the second pass is what is implemented by n minus I minus 1. That's an optimization that you can do good. It's not going to harm you if you do up to n minus 1 in every pass, but it's just a wasteful comparison operation that you're doing and wasting money or power in doing a compute of sorts. So let's move on. Let's write a code. So j equal to n minus 0 n minus I minus 1. Then if your a of I, which is your if a of j is greater than a of j plus 1, that is your leftmost element is greater than the rightmost element. So take it up, bring it here. A of j is greater than a of j minus 1. Then you just j plus 1, you just need to swap it around. So in Python, your swapping logic is pretty much very easy. Just do a of j comma a of j plus 1 and equals a of j plus 1 comma a of j. Now just to understand, just to see how the array gets sorted, let's just start printing the array after every pass. So let's say something like print pass, then your I plus 1. So make this an string, move all the way to the right, enter, print array, then comma a. Let's run this. It's running. Hopefully no errors. Okay, fine. I didn't start my kernel, so my kernel is starting up. Let's hope it runs pretty fast. The algo itself is pretty fast. It's just my kernel is getting started up in the background. So n is not defined. So basically n here is the length of your array. So you can do n equals len of a. Now it should start working. Hopefully. Yep. So you can see the same representation of our passes. So pass 1, 5 gets moved all the way to the right. Then pass 2, the next biggest number, which is 5, again gets moved all the way to the right. Then the next biggest number 4 gets settled in its place. And the last two passes, though it's not needed in this case because the order it just worked. After third pass, you got a sorted response. You still go through it because you don't know if it's sorted. To check it's sorted, you can do a compute and you can run each pass after doing a comparison, after doing a check if the array is sorted, which is another optimization that you can do. So the code is as simple as this. It's just this. Enjoy. That's the simplest code that you ever write in your whole damn life. Moving on, we have some pros and cons about using this algo. So which would be pretty good to know in case of an interview. So basically time complexity is O of n square. That is, if as the number of elements increase, your time is going to skyrocket. That's the only con of this algo. It's very simple, it's very easy to remember, it's very easy to code. But yeah, if you have a very large data set, then yeah, you just have to pay the price of money, pay the price of taking time to sort your arrays, which is not acceptable. So we move on to the pros here. So the pros is the space complexity is just O of 1. You don't need any additional memory, you don't need any sort of temporary array in order to use them, in order to sort stuff here. Then it's a very stable algorithm, that is the relative positions of similar key value items is preserved. So for now we are using you're doing sorting on a very basic comparison based on values. You can also do this on on your academic name register. So you can use a combination of your age and your name and sort it and the alphabetical order of your name and your age to sort stuff. So in this case, let's say the best example of this will be, let's say two people with the same name, same age, who are just being distinguished based on their PID, are in a class. Then if let's say Bharath, Bharath myself is at position 1, is position 3, and another Bharath is at position 4, then always I'll be at position, irrespective of how the sorting happens. Based on how the sorting happens, based on the comparison rules, this relative position between myself and another Bharath would always remain the same. That's what a stable algorithm means. So that means what we see here, you can see the 5 and 5, though near now, though in the starting, though they were near to each other, at the end of the sorting they again came back near to each other. That's what stable algorithm means. Yeah, I hope it was quick, easy, fun to learn, and easy to remember. Thanks a lot for watching.